So I'm going to go through a little quicker because this is not the first time you've seen OO, but putting it in terms of perspective of Java, of course, there's some differences. So this is a rather busy looking diagram, but it includes some rather important information. Oops, actually, let's move this off on the side here because it implies that it's for this one, it's separate. Okay, so I got a comparison between Java classes, Python classes, the generic syntax requirements, and then an example. It includes some of the parts that I have had in the previous example, but it also includes more based on the additional stuff I've taught. A question here, what's participation quiz? No. Someone said there's participation quiz on the outline. I didn't put any of my participation quizzes on the outline. There are no participation quizzes on the outline. They're actually Dropbox submissions. Those are Professor Hudson's. Those aren't quizzes. Those are Dropbox submissions. So if the Dropbox submission's a bit off in terms of date, ask him. I'm not aware of that. But the participation quizzes I spring in class. So the due date, I usually have the due date after I spring it because I can use in one class, then I might have the leeway to be able to do it a little bit later. So it's sometimes later than when I actually run it. So to be clear, participation quizzes are quizzes in D2L. And those are ones I spring on you in class time. The ones that are listed in D2L particular due dates are Dropbox submissions, like an assignment. And that's something that Professor Hudson's looking after. There is, I don't know if he put an announcement, also I suppose a bit wonky with 233. The outline itself, the official PDF course outline, I did mention that. Yeah, it should be the 14th. I think he made an announcement with the TAs and the instructors, but I'm not sure he actually made an announcement in the main 233. I couldn't get into it because having some troubles with that. Okay, so over here, here's the Java class, here's the Python class. Let's look at the access modifier. You have seen private now, so I'm including it. Private access modifiers. In Java, it's far more explicit. If it's private, we use the keyword private. There is they try to sort of implement an equivalent over here in Python. You may not have actually seen this. You've seen the self, but what happens if we put that underscore in front of an attribute? Well, with the latest version of Python, I did a test here. You still can actually directly access it outside of the class. Inside the class, well, we just have to have that self.h, just the equivalent of this. Outside of the class, if you go through some convolutions, you can still change it. So it's actually not truly private access, because if you try to access it outside the class, it's private, it's syntax error. Here, it's not a syntax error. That's one thing. So it's not truly implemented to protect that attribute, so you can't change it or even access it outside the class. That's one thing here. It is almost like a stylistic convention with constants. With constants in Python, there's no keyword to prevent you from changing it. You just capitalize it and say it's unchanging. Have something like this. Recall. You're supposed to capitalize it so other people know it's not changing. But there's nothing in the syntax to prevent us from changing it later. And it becomes a logic error, which is awful. Well, so this is a suggestion. Don't change it. You should not change it, but you can. The syntax doesn't prevent you. Well, in this case, it's a stylistic thing saying outside of the class, you should not access this through a object, but you still can, which is somewhat better than the older Python a few years ago. I actually had a debate for another instructor in 231. She wanted to have an exam question that said you cannot directly call a method with the underscore, like the init. And I said, au contraire. And I banged out an example and I showed her. And she said, well, that's awful. You shouldn't do that. That's true. You shouldn't do it. So this underscore init is telling you you shouldn't directly call it to an instance. In other words, what you shouldn't do is, well, I'll put it over here. So somewhere else in my program. So I've created a reference to a person object in Python. The underscore in front of a method is indicating you should not directly call it. And in the old Python, you could. It's just harder to do this. And that's pretty awful to do. You're creating an object for another instance. Shouldn't do it. Yeah. Now I haven't tried calling a method. I have tried this thing, the attribute, and actually in 231 I showed this because Professor Zal brought up encapsulation information hiding. It doesn't do it well at all. It just suggests it. So if you see other methods, seen other methods in Python where we have that, there's the str, for instance. And I bring this up because there's a rough equivalent in Java. I think it's called equals in Python. You should not directly call these ones like this. I think you still can. str basically returns a string representation of the object. So if it's got non-string values, it converts it and glues all the attributes together. You shouldn't directly call it because normally, if there's a string method implemented, so if this has a string method implemented, str, and so on, then it'll call it automatically. If I create a person object and I pass it to print, calls the underscore str. There's an equivalent in Java that we'll probably talk about because it's so bloody useful. And if we don't talk about it, there's a default one. Let's say, again, I assume we have it all here. This calls automatically p dot, the method is called toString. If you don't implement such a method, I haven't yet named my classes, then it calls a default one, which doesn't display useful information. You'll see a letter of the alphabet and then says at something something. That's if you know where to look in documentation, class object, that toString method says it returns a hash code. It's kind of like a serial number that identifies each object that you've created, essentially. What you can do is write your own version of toString to display useful information. But in terms of private attributes, some people refer to that as encapsulation. This is how you do it in Java, as you see. This is the sort of equivalent in Python, pretty awful. So you were taught to actually create your attributes here in Python. Awful. They don't follow standards. When I first learned Python, I actually put it right here. This is different. This is, if you do it here, self.population. This is a class attribute. So you don't follow standards. It's hard to, which makes it even worse is it's hard to tell that it's a class attribute because things are typically immutable. So you start filling around with it and you think it's okay. It's actually an instance attribute. If you make this, say, a string, something that's most things are immutable. If you make it a string that's mutable, you have one string here, and then you have multiple strings. If you have another string here and create multiple objects, each one of these objects for this string will have its own value. Of course, give each object a different value. But this one will be universal for all the objects. So this is something I didn't talk about previously. This is how you basically implement the equivalent of static here. Instance attributes you define here and not inside the body. Completely opposite. If you define something inside the body of a method, then it becomes a local, even if it's constructor type. Whereas defining something inside the body constructor preface of self makes it an attribute. Yeah, annoying. And one attribute for each object. So it's a recap of what you've seen, but it includes some new things. So it's built on the recap. Okay, someone's just following up on the other question. Okay, defining methods. Yes, you have seen this, but more formally, there's additional things that you need to know in terms of syntax. So if we have Sage, for instance, this includes the syntactically required parts, but parts that are you could leave out and it'll compile, but you really shouldn't leave out. The absolute mandatory parts in terms of syntax, return type. Even if the method returns nothing, and there's two cases that can return nothing. Just banging out a really quick example here, so I haven't included everything. And I'll leave a space here. If I have no return, it has to have a void. Void means I've returned nothing. No return, I haven't returned anything. Or if I have a return and there's no type that follows it, again, it has to be void. And that's not the same as null. Null is pointing to no address, but that's still something because something that contains null can contain something. Can contain something is not the same as nothing at all. So return type has to be included, even if it's void. Otherwise, you can include one of the built-in types of primitives, existing Java classes like scanner or string as examples, or even classes that you define in your program, as long as it's visible in your program. So if you put it in the same current working directory, it should be visible in your program. If you can instantiate it, and you can specify as a return type. The method, well, that's a given. You have to put a method or function name here. Now, not mandatory, but you should really include these because stylistically, and it can lead to some problems. Intuitively, the public means it's viewable, but it's usable. Think about it this way. Why should methods be public in general? You're writing some functionality, features, code that can be called. Making it public allows other parts of your program to use it. Or if you release this class in the general internet, it allows people to use your code. You are releasing it so people can use it. Private, there are certain cases where you want to make a method private, but they're very rare. Say it's accessing privy information, someone's credit information or something. You might have an encrypted attribute, and then when you're actually decrypting it, then it's a private method, does decryption, a very controlled fashion. But that's a very, very specific example. As far as I can think of right now, all your methods, unless told otherwise, should be public. But just because it's not, your program will compile out, it might say, wait a minute, it compiles, you're right, you shouldn't leave it out, because if it's neither private nor public, it's a third access modifier, and that may mean that your program can't access it when it should. There's a need for that third one, which is called package, but you shouldn't just leave it because you're being sloppy. You don't have to make methods static, that you've seen. And most of the time, you should not make them static. Static methods are procedural, not OO, and Java's an OO language. So that's why it's not mandatory. Parameters, given. You don't always have parameters being passed into a method. So that's why the syntax doesn't force it on you. The method body. Well, you have to have the curly braces to possibly enclose a body, but you don't actually, you can have an empty body. Of course, having an empty body or statements, having statements in the body, non-empty body is not enforced by syntax because you could be in the design phase. But if you're not in design phase, just outlining all your methods and they're all empty, if you're not in that design phase, then they should be non-empty because why are you writing a method that doesn't do anything? So yes, you can have an empty method like this, but what's the point of bothering going through all this if it's not going to do anything anyhow? Now in Python, because it's based on indenting, you had to have at least one statement. It could be a print, or it could be something that didn't do anything, the pass statement, but you still had to have it. Now, theory like this is pretty important because if you don't understand what's necessary, and cases when we get to it, private and public, we will get that shortly, then you're going to have problems. But possibly, Professor Hudson, you probably noticed in the first quiz, not participation quiz adds some more confusion. There's the quizzes that are non-participation, class participation, Theories, he likes to quiz on theory as well. So things like this are potentially fair game. Don't ignore it, besides being important. Starting execution point. We are now going to get into classes OO with at least programs with at least 2 classes. So in a real life program, you have more than 2 classes. Many classes. I've actually saw an RPG that was written in Java. For a while, the source code was available. That consisted of 1 to few hundred classes. So someone can figure out how to run your program. The starting point should be the one that contains main, as you know. It should be in a way so that it's intuitive to figure out which one it is. Example, if it's a program that has a name, this one's an RPG, not the one that had source code. This is a commercial one. The other one was just someone's project. This one's the Icewind Dale. The executable, there's actually, this is just part of the files in that install directory. And then there's many folders in some files as well too. ID, so they shortened it. So now, granted, when you're using a novice operating system, Windows, it hides it for you. So when you do this clicking here and you try and run an application, it figures out where it is. But behind the scenes, if someone had to know where things were located, they follow that convention. I'm just showing that in real life, they follow these conventions, even though typical users don't have to find this. Programmers, on their hand, who are developing updates and whatnot, have to know these details. Other ones, Word, for instance, is Word.exe. Dropbox, Dropbox.com, the cloud sharing, not Dropbox is part of D2L. That's the name of the starting execution point. If you don't have a good name, then the conventions are driver. It's a driving point. It's not a great one. Driver contains main or start. However, including a README file, if you're not familiar, README is information on how to use the program. And as name implies, you're supposed to read it when you're using that program. Include things like this in your assignment submissions. It doesn't hurt to do it. Okay, back to access permissions and some details. Now, more than just showing how it works, what's the benefit of it, and what if you don't follow these conventions? That's what I'm about to build to. I won't get to all this today, but I need to have fairly clear in your head how they work. So the access permissions, we specified from the attributes and the methods. So we have class person, we have another class over here. These are the access permissions in blue. Inside a method of another class, I purposely didn't pick main just to show we can instantiate, create objects in classes and methods other than main and the driver. So we create a person. That's possible to access because we're calling constructor. The constructor has public access. There's a very rare time when you actually have private, when you don't want people to create objects. You just want to have one object, but typically it's public for a good reason. So it's explaining the whys. Then we have a reference to an object, a person, called sayName. sayName has public access. So this is allowed. Right now we're outside of class person. Inside, even though name is private, we can access it. There's a reason for all this. Syntax error, private level. If we try and access name, unlike Python, where you can access the underscore field, this is a syntax error because it's private. Whether we set it to null or something else, we can't do it, nor should we. And there's a good reason for this I will build up to. With this example, there isn't too much to it. It's a completion one, but it's available for you to run and try. There's the odd IntelliJ issues over here, so I won't get in the command line. We have private in the name. Let's see. So public, we're able to call the constructor because constructor is public. sayName is public. So it's just a complete runnable one. That's the point of it. So it's just a build up as a runnable one over the previous. And over here, I've commented this out, but this is a copy paste of the error message you get from either JDK, the command line, or from IntelliJ. Can't do it, compile error, private access, defined in person, nor should we. I haven't explained the why this is a good thing. It still seems like a pain in the butt because free and clear, you were doing this all over the place with 231 and object-oriented programming there, code object. It's really awful essentially doing that. But even if you were just doing it in Java in that first class, I would tend to let it slide because it's your first touching of OO, but then I'd quickly bring it in this course. So I have reviewed the private public here and some runnable examples. And if it's private, we can't access it here, so I'm building into something, then what if we need to see the person's name here or change it here? How do we do it? That's the next step. And then the why is the step after the next step. If an attribute is variable attribute is not, you can't see it, you can't change it outside definition of a class, say we need to be able to access it. This isn't actually the proper way of doing it, but I was trying to keep it simple. I can actually see the value of the attribute. This isn't the proper way of doing it because essentially it's very constrained. It only displays the name attribute with text-based output. It would be better if we had a generic one that could basically just return a name, and that name could be used not just for text-based output, but for a graphical user interface. That string is passed to GUI control. It could be used for the internet, passes it off to a client across a network or the internet. And that's where we have the standard. The typical standard is variable attributes are set to private. Consequently, it's also standard where each variable attribute has two methods that go with it. One to be able to see the current value, the get or accessor, and then one to change it, the set or mutator. So in this case, the advantage of the age, for instance, rather than having system.out.println, I take that integer I return, then I can use that integer and display it depending on my interface. It could be a text-based one, and I pass the return value to println, or it could be a graphical one, as they say. So this adds more flexibility. And one thing from talking to Professor Hudson is with the assignment 3, if you design essentially the first assignment is text-based, assignment 3 is graphical. If you design your early assignment where you don't assume a certain type of interaction, input and output, then it'll be easier. If you assume, like this example, it's only text-based output, then you're going to have to make more changes. So it's something that just occurred to me, a conversation I had in a meeting a while back. But it ties into the accessor mutators. The only thing that an accessor does is just return a current value, typically. If you actually have other things where it's only returning it via a certain certain display method, text-based graphical, then you're constraining your program. So an example that implements accessor mutators. So we have two attributes, name and age. One constructor where we set, as we create the object, we set the attributes to this. Now, one other thing I'll mention is it mandatory in an OO language to implement constructor? No. If I had absolutely no constructors, then the term is, the languages I've seen thus far have what's called a default constructor. Even get rid of this. Default constructor looks like this, but it comes with each class so that it will set the attributes, in this case, name and age. When I create an object, it'll set the attributes to starting values, and then later on I can change it. Because these two are private, yes, I can access them and change them right inside these methods of this class. But to be able to see them, I need accessors for each one, mutators for each one. So now the driver, where I'm actually, so I have this documentation explaining these are now in separate files. That's in person, that's in driver. I create person. It calls, let's make a screen grab of this. So you can see, so you don't have to jump around, although you should have your notes handy. Oh, here it is. Some waiting room here. Shrink this a little bit. Not very, doesn't do it very well. I have lost screen real estate. Here. So here we call the no argument constructor. And we set name to default, age is 0. If we had a no, if we didn't have this one, essentially it wouldn't set the name to default. It'd probably set it to an empty string. Here we pass to a different constructor, an overloaded constructor, string, and an integer. So we call the different version of the constructor, and we set the name to the snipping tools. These ones disappear. The name to the name parameter that we pass in here, the age field, age attribute to the age parameter. Fairly straightforward here, and be able to access these values. What I have here is this is extra little comments when you run the program, be able to see. Okay, for the one where we called the no argument constructor, get the name, get the age, and run this. Speed things up, so I'll go through the command line rather than IntelliJ. Example 2. Another advantage of the naming of the driver, I can just, when I run it, I can use the arrow keys and go in a different directory and just run driver. So let's see. So I have the no argument constructor. We have the default values because that's what we set it to, default and age is 0. Now we can change the attributes, although we create it with certain values, set the name to Dragon Bait, age is 17, and then just indicate it's the initial object with the no argument constructor, and we have Dragon Bait and 17. And case where we call now the constructor that takes a string and integer, that's this one. So the parameters we pass in here are the values used to set the attributes. And then we use the get name, get age here. Nameless bard, because whatever the heck is it? Oh, must be on a different screen. Oh, the code must have set to nameless bard here, so I have to pull up the code. What's up? So that's for mutators. Oh, wrong one. Oh, it was right in front of me. I'm blind. Nameless bard and 60. So you got the nameless bard and 60 here. Now at this point, is there questions? Now some important issues here. Someone's image makes it look like they're raising their hand. Like a little yellow, looks almost like a hand raiser or a thumb, but so keep looking over there. Okay, over here. This is the classic way when profs teach it this way. This is how textbooks do it. If you look at online resources, accessor mutators starting a basic OO program. And they have attributes that are private. They'll say the same spiel, and then they have accessor mutators. And that's all they'll say. And when I was taught OO, that's essentially all I said. You might be thinking, I remember clearly thinking at this point that the prophet said you have controlled access so that you don't set these to invalid values. You have a method. And I looked at his method. It was just like mine, essentially. You have a parameter, set the attribute to that parameter. And I remember turning my classmate, either in class or afterwards, I said, so what's the point of this mutator method? Basically, whatever the person passes, if it's an invalid value, it doesn't matter if I do it this way, because it's going to be set to an invalid value, or if it's public, say we have person, pretend it's public, person 1, age, and I set it to an invalid value here. If I pass to set age right here, I can pass it -1. And with the classic examples, it still doesn't do anything. So I thought, so what? Well, I'll answer the so what in a little bit. There's still some benefit. There is an actual benefit. I'm trying to show you the benefit of the accessor beyond what typical other people teach, so that hopefully you understand it and will follow this approach. But I admit, well, actually, I did do this sometimes when push came to shove. It seemed like, let's go back to this, even with this small program, Students look at this and they don't see the benefit of OO. Among profs, we've discussed this. How do we actually get students to see this? If you wrote it the Python style, it would be significantly shorter. We would have attributes. These ones would be created in a constructor, and we'd have, say, 1, 2 constructors, that's it. And we wouldn't need these 4 methods. The programs are bigger, and students don't see the benefit of OO. To some extent, you need bigger programs are mimicking real life, their simplified version of real life software. And the idea of having a project is you work with multiple people with a bigger program, and the rationale is to help you see the benefits of OO. Because a common argument among many profs, including many in this department, is students can't see the benefit from small programs. Au contraire, at least you won't see the same benefits I'm about to get to, because this is a small program, but you can show some of the benefits of OO. It looks big right now, and you think, why bother? We'll get to that. But back to this. Partly because I didn't see the benefits at the time, because I was a student, not at first. Eventually, I figured this out. And partly because with the programs we had to write, it was second-year course, we had the 3 weeks, 2.5 weeks of OO. It was very complicated. The programs weren't big, but they were dense. Use recursion a lot, for instance. When push came to shove, sometimes I would just make things public and say, heck with that, because it's adding an necessary complexity. What's more, I remember some of my classmates do it, so it wasn't that I was alone. How many actually do that backslide, essentially do, or they might make it procedural as well too. C++, we learned C. C is essentially C++, same syntax. They let the genie out of the bag, unfortunately, where they taught us C and then we learned C++. We learned procedural programming in C++. So people made it procedural, and then they said, well, let's convert to OO. Also, they made things public. But leading to why you have accessor mutators, why it's done in practice. Part of it, I've said it in the abstract, is by only having the variable attributes accessible here and changeable here, well, accessible. If it's really private information, this isn't necessarily private, but could be something like your social insurance number for an employee object. Then maybe you can have some mechanism to determine if the person enters in login credentials or something to that effect, or biometrics, eye scans. With these ones here, with age, for instance, age shouldn't take on negative values. The exact range of valid values for that integer, it's the person who writes this class is in the best position to know. You wouldn't want, say, for a human being to set the age to 1,000, something that's completely invalid either. Now, with the age, well, what's the specific cutoffs? No negatives. Where do you cut off? That could depend. What's the oldest person? That's a possibility, but depends where you look, what records. 118, I think, is the youngest, most conservative estimate. But in other cases, to reduce the possibility of side effects, that's where you call a method and then you get unexpected effects. You minimize where you can change things. With locals, yes, you can still get logic errors if you set it a local to wrong value, but you minimize the damage control where you have to look in the functions, in the function where it has scope. In a similar fashion, if I screw up when I actually have private access, then say age is set to an invalid value. If only these methods, and I do some additional things besides just this, can change it, then I can narrow down my tracing debugging. And now the things that I'll lead up to in the third version, I'll have a second version of this program. The programmer who wrote that person class will know, and that person can add in some code to prevent something stupid to having an invalid value set. Another one besides just primitives is for references. Could be an assumption inside a method that a reference is not null because a reference parameter, because we might need to call a method. If it's null, then it's going to have runtime exception. Some other assumptions that may be necessary, not just range values. Having access only changing, the ability to change through mutators can reduce these problems, as you will see. Another person sitting in the waiting room. However, if you don't understand the why, I've said the smart aleck approach, but it's actually in this case a good approach, do the why not. If you understand why you have to do certain things, then try to ignore that requirement and see what happens. But I do it in a test program, or at least a backup of my important assignment so I don't screw it up. So with this example, if you have complete freedom, it's easy to change things, but it's also easier to screw up. Class inventory has shrunk significantly. The equivalent starting class rather than person who has inventory, because in this case, I could set up a rationale for the range. You can't have a negative inventory, sell more than what you currently have. And the 100, I used to work in retail. There's only Market Mall, actually. Very small store we had. The back area was about like so big. Well, bigger than this, maybe not as wide, but longer. Only so much stock we can put, electronics. So here's the valid range documentation. Stock level is wide open. We have a constructor here as we create an inventory object for a store, and we can set stock level this. But otherwise, it's small. I think smaller is better. Not necessarily. I mentioned that with the ternary operator. Instead of branches, we have that question mark. It's not clear. If it's smaller and it can lead to more logic errors, it's not a good thing. So, usage scenarios. So this is just the relevant parts of the driver class in main. We have, I used to work in Market Mall before I went into computer science. We have starting inventory for Market Mall, 0. And this part is essentially the scanner is just to pause the program at various points. But I have screen grab to save time. So at this point, we check the stock level. We can directly access it here. You see it's 0, as it should be 0. Then we get a new shipment. So from our warehouse, periodically to bring in some electronics. It's not unheard of. How some of you have worked in retail before. It can get hectic. There's that old adage when the manager says, I don't think it's going to be any more busy today. It's going to be pretty dead here. And some of you guys can go home. That's when a horde of customers comes in. And then you get busy and you're the only guy in the store. So sometimes we make clerical errors. There's nothing to prevent something like this. Stock level, keep in mind, sure, the guy's documented it. And I've seen student programmers say, I've documented it. But this is insufficient, just put in documentation. I would suspect, for instance, say with the scanner class, that's a basic text input. Very few of you, when I polled this morning, said show of hands, how many of you read the documentation for scanner class? No one stuck up their hand, nor did I expect anybody to. So just burning a requirement like this in the documentation for class is insufficient. And this person who's using the program isn't, now this is text-based because I'm trying to keep it simple and we didn't get user input. It could be a graphical system. Isn't going to be looking at the source code. They don't have ability. All they have, they're running a binary. So they make a typo. That sort of thing happens. This program doesn't prevent it. It doesn't idiot-proof it, prevent cases, prevent errors from happening. We display stock level. Oh no, we have an error. It's 101. The guy's a new guy. He panics, so he tries to fix it. Makes another typo, tries to fix the stock level. It's even worse. You're fired. The show The Apprentice used to be on. So now, let me ask you this. I will do a show of hands here. There are at least three people who are involved in this simplified usage scenario of software. I call it clerk, basically. I wasn't a clerk in the store, had to do other stuff, but I had to do clerical tasks like this. The user of the software. There's the person who wrote this driver class. The driver class is using the inventory class. So that's the second person. The third person, and sometimes there might be overlap, but frequently in a real life program, you have multiple classes. You divvy up the work as you'll do the project. The inventory class. It's very much possible that this person is separate from the person who wrote this code is different from the person who wrote this code, the driver. So a show of hands. You have to pick one. Don't limp out. And you can't pick more than one. You have three possibilities no, you can pick more than one, actually. I should say that. But you have to pick at least one. Show of hands. How many of you think that fault lies with the clerk? If you do, raise your hand. Okay, no hands. Interesting. How many you think, so the clerk is the one that did the data entry. There's the rationale there. How many you think that it's the person who wrote up the code for the driver class? That's where the errors actually occurred. If you think that the author of the driver class is at fault, a show of hands here. Hopefully you're not wimping out and not participating. Third possibility in this case, show of hands if you think it's the author of the guy who wrote the inventory class. Show of hands here. Okay, now people are participating. Hopefully it'll be everybody because no one participated in the other ones, which. Okay. Majority of people said it's the inventory class. Now I'll ask you, other people, so you can lower your hand here. Thank you for participating. Besides sticking up your hand, the question, why do you say that this person is at fault? Now show of hands for anybody who only got one hand left. I don't know if it's a see Hadge, asked to unmute. I don't know if you have a legacy from that or your hand's still up, so I'm assuming at this point you can say, why is this person at fault? Okay, quickly load that. Anybody else want to describe why do you think that this person is at fault? And gotta be at least one person. Majority of class said it was this person. Not looking for a tricky answer here. Oh, shy. Well, at least you participated. Well, the fault lies in this one. Stock level it relates back to what I described. If this one has assumptions about this attribute, could be null, it could be a certain range, then the person who will be the best position to know this is the author of this class. Furthermore, because this person has the best knowledge, this is the person that should be responsible for idiot proofing, physically preventing, say in this case, the stock level from going too low, lower than this, or too high, but this person did not. It's not bad. Maybe it means you're sharper because in the past, at least, when I pull people with such an example, I had at least some people put blame on the driver, the author of this one, and then the user. No one did that, so that's perhaps you're getting sharper over time as a whole cohorts. So it's this person, wide open. So with a proper implementation, now this one has a private level set for the variable attributes, but it does more with the accessor mutators. So I've gone beyond this. So it's turned this to private. However, now the set stock here, well, I've also created name constants to specify the min and max range. But when I actually try to change it, this is the only place, these methods are the only place I can change it. When I actually do it properly, if I try and set it too high or too low, it physically prevents it. Only if it's within that valid range does the stock level actually change. There is, in a small example, giving you a little idea of the benefits of OO without having to have a gigantic software project, without having teams. So I beg to differ with the people who say, okay, well, we need to have big projects to show the benefits of OO. Now, the benefits I have here won't necessarily be benefits that you'll see in the project, but at least you see some benefits. Another thing I thought about since then, last time I taught the course, is I never said anything about this. The accessors, I briefly mentioned this. By having an accessor, if there's no problem in seeing any user of the software, the inventory software, no problem in anybody seeing it, then fine, we just return it. However, by having this only being able to see it through querying the get stock, we can later on add code and say add in some authentication to prove that you are allowed to see this privy information. If we just set it as public, we would lose that ability because you might say, well, here, why don't I set it here to prevent the stock level? Two things. One, I'm going to change it multiple times. So I basically have to take this check that I do once here, and I have to do it every time that I use the inventory class. So it makes the program actually bigger. OO can actually make your program smaller. because I don't have to do the same check to get it again. Any questions about this example here? Hopefully this gives you some idea of why this is actually done in practice. This is a good thing. It's narrowing the scope where you can see it and where you can change it, but even with this tiny example, it gives you some idea of the benefits. Another question for you, so you can understand. I'd be wording things carefully, so I looked up just to make sure I'm thinking my words before I say it. I said, all variable attributes should be set to private unless you have a compelling reason to do otherwise. I said variable attributes. What if it's a constant? Is there a need to make this final? Is it different if it's a constant versus a non-constant attribute? Thoughts about that? Well, we think about, say, an example here, class math. An actual Java class that comes built in. It has within its class definition not an int, I think it's a float. Oh, float I. Specific. Do you think it matters if this is private or public? Something concrete here. It makes a world of difference. It's actually public. And you can look at the API to verify. Most cases, constants are public. Why? Because the idea here is we're making this private, prevent it from being set to an invalid value. Public, well, it's final, it can't change. So by definition, by the syntax, we can't set it to any other values other than its initial value. Unless for some reason, maybe it's private information, its constants are typically public. Variable attributes that can change are private. Here's something new I wanted to actually add for this semester. With 233, there's only 3 hours per week of teaching. One advantage of 219 is that it's 4 hours. Whether or not it's in person or not, I try not to really exceed the time by a significant amount. So the bottom line is to have more detail to actually get into technical explanations of the parameter passing. Now, this pass by value definitely exists and there's no change here. The cases we're seeing the effect of pass by values to copy data from the argument into the local variable, and that local variable stores a copy information. So that means that if inside a function or method, we change the value of the variable, we're changing a local and not what was passed in. So essentially we just change a copy. Pass by reference, that's actually a little bit trickier. The bottom line with pass by reference is languages that actually implement it in a practical implementation and a technical sense is when you pass in a argument with pass by reference into a function or method, changes inside that function or method will then change the argument. After the function or method ends, the changes will persist. Now, whether it actually is implemented or not, that's a little beyond the scope of the course. But we'll talk about this part, pass by reference. The name is implying you're passing a reference, and a reference stores an address. So this is why I've actually referred to passing addresses as pass by reference. It's compatible with the name, and it's largely compatible with the effect that you see. You copy what's stored in the reference, which is an address, into the function or method. Again, just like with pass by value, you have a local variable, but this local variable now stores an address. Because you have the address, this allows that reference, that local reference, or the original reference to change the original. So in terms of practical effect, pass by reference will still change the original. And that's where I left it off with 233. But there's an addendum. Now that you have some time here, I want to add additional technical details. Hudson, I believe, says this, and he is correct technically, as well as if you look online. Does Java pass by reference? Most cases, technical sources will say, no, technically that's correct, even though it passes in a reference, which is kind of on the confusing side. Without really explaining all the actual details of real pass by reference, it's actually not passing address, it's something else. And languages that do pass by reference is C++. So if you want to delve a bit deeper, you can actually try and examine how C++ passes parameters, truly pass by reference, versus languages like Java, which copy a address. Now, your bottom line view. If you're asked on a quiz or exam, a theory type question, a theory is actually asking about technical details, how things are done. Does Java actually implement pass by reference? Hudson is correct, and those technical references are correct when they say no. C++ is one of the few languages that implements true pass by reference. That's essentially in the language details. In order to get into it, I actually have to get into compiler, translator, theory, and that's a 500 level course well beyond the scope of this course. However, in terms of actual effects, when you're writing a program for code trace, if you have a parameter that passes in an address, and that address is stored in a local, say we have this local called person reference, we pass in a reference to an object. Person reference contains the address of the object. And as long as person reference contains the address of the object, and we haven't changed the address here, we're using the mutator to change the attribute, it acts just like real pass by reference. So in practice, Java, even though it passes by value and the value copy is an address, it largely has the same effect as pass by reference. So no, technically it doesn't, but in practical senses, in a practical implementation, it basically behaves the same way. Professor Hudson brings it up. He didn't actually bring up this, but I believe he brought up this. How does pass by value and reference implemented in Java? Basically, it's by the type of the variable. All the primitives are passed by value, no choice. You make a local copy. Passed by reference, well, anything that involves a reference. That includes objects, arrays, might be other types as well too. Yeah, might be other types. I'm trying to, something that doesn't fall under either category. So you don't have a choice. If you had an integer in C++, in Java, you can't pass it by value. Just quickly, not for a quiz or an exam, critique of it, I don't like this implementation because there may be times that I want to pass a primitive by reference. So for instance, this is C++/C syntax, which is very close to, which is pretty much Java syntax. Okay, so just like in Java, I have to specify the name of the parameters and the type. By default in C++, this is going to be passed by value. But if I want to pass, say, some of these by reference, say the first one, the third one, it's beautiful. I just put an ampersand here, going from memory. It was that simple. And now, inside the method or function, if I change X here, it doesn't change a local, but it changes it inside whoever called it. So easy to do. And another language, it does something like this. It's not the same syntax, it's not an ampersand, somebody else's Pascal. So there's languages that you can pass by reference and value independent of the type. And that, personally, I find that this is a better approach. But in fairness, with Java, this for some reason tends to be the trend with newer languages. Pass by value versus reference is determined by the type of the variable. If you say have to, you have two simple types or more that you need to change inside of a function, the changes persist. What can you do? Back to what you've been taught. Essentially, you have to involve references. So you could use wrapper classes, which is kind of overkill if it just have an integer, or maybe essentially a more clunky form of what Python does. You have an array. Rather than passing these three things, you pass an array that contains the elements if they're all passed by reference. And because the array is passed by reference, then the individual elements correspond to these values. Far more awkward. But that's just a critique of Java's implementation. Miscellaneous topics. Before I get to that, I have a quiz for today. Participation quiz, not Professor Hudson's. So should be opened up in D2L. So start writing it. You have up to 7 minutes. I'll double check it's open. Yeah, third participation quiz, it's open, it's not hidden. So I'll stop the recording because it's, I don't know, 7 minutes of dead air. Stop the sharing. And give that a try. Pause the recording. Hudson actually put in the control section and he put branching, looping, static, and a whole bunch of things, lumped it all together. And then he had this stuff. I put it in here, not because it's so old, but I put it because he could test on it. But rather than making just a short section, I call it miscellaneous programming concepts. I better get this done. So I put it in here in case people know only, this is not old, you're right. Okay, static, non-static, a review, but there's something extra that he has here. Static called through the class name, and the convention, the class name is capitalized. With system, you know that it's a class because it's capitalized. So it's class name. We haven't instantiated any instances of class 1. So that gives you a clue that we're dealing with something static, calling through class name. C2, non-static, so we need an instance to be able to call it. Okay, optional parameters. Review of what that means, the terminology from 231. So I actually have write my example. If you want to see, there's a shortcut bookmark link to review this. Optional parameters, this display function, it's a Python function here, not a method, is we've got one required parameter. So we have to call display of at least the student ID. These two are optional, and if we don't include it in the call, we include in the calls here. So the age is going to be this value, 18. Name is going to be Smiley. But here I only have student ID number. So student ID is going to be this number. We didn't include age, so age is optional. It means we set these default values. We didn't include name, so this person's going to be no name. That's a quick review of how it works. It doesn't allow for optional parameters in Java. Given if I was doing it, I wouldn't even talk about it if it's not implemented. But he shows here's how we can basically simulate this using method overloading. Overloading, same method name, different parameters. So over here we call this display method. And let's see if display here. Oh, so we have two different versions overloaded. One that takes 3 arguments. Integer, string, and an integer. Integer, string, integer. Another overloaded version takes no parameters. Now this one isn't overly interesting. This isn't hard. You should be able to handle this. How do we handle it? It basically just displays the 3 arguments on screen. How do we handle it if we pass no information display? Basically, we just have default values here. Just catch up a bit. The variable length arguments. The length for a number of arguments vary. So for instance, we have this method and there are 2 arguments here, a Boolean and a character that are required. But what varies is the number of strings that you pass to it. If you don't have much variation in the strings, what you could do is, the technique for it is if it's either 1 or 2 strings, you could overload the function. However, if you have from 0 to n is some counting number, greater than 0, potentially up to infinity, that's not going to work, even if you have variation, 100 different variations. So there's a more efficient method, the variable length arguments. So how to define this in Java? The variable length arguments has to be at the end of the parameter list. So you have the non-variable ones, and how you specify the type of the variables, they all have to be the same type, and then the ellipsis, and then the name. And what we have is an example here. That's where we have the code snippet when I was calling variable method. The non-variable, it has to take a Boolean and a character, and it takes 0 or more friends. So it will display the fixed arguments here, the Boolean and the character, every time, whatever we pass to it. And if we don't pass those, then we get a compile error. And now it will compile with 0 strings or more strings. And to be able to iterate through the variable number of strings, we have our old friend, the for each. The friends is basically the variable number of strings, and each element is a string, a friend out of friends. So you can see naming gives you an idea how things work. And for each friend that we retrieve from that variable number of strings, we tab it so it's easier to see the variable length argument and then display the friend. So if this program, if I call variable method and I pass in the two fixed, the required arguments, the Boolean and the single character, no strings, compiles. Then it displays the number of fixed arguments, as I said, first. And then it's about to display, we have this message saying we're about to display my friends. This loop doesn't execute because there's no string, nothing to iterate. We pass in two friends, Jamie, Stacy. Again, this, whatever we pass in, so whatever we display here, that false, in this case now it's true, appears. So we can have some variation in the data for the fixed non-variable arguments, but we still have to have the two. With these two, well, that loop iterates 2 times. We pass in with one variable length argument, and the loop only executes once, and Sammy appears. So it's there if you need it. It's another tool in your toolkit in addition to overloading methods. Null. I have talked about the null, but just to pound home the point, null versus void essentially returns nothing at all. So this one oh, sorry, this is Python. I had to think for a sec. Otherwise, in Java, it wouldn't compile. This returns nothing. Now, it's referring to something, a reference, but the reference doesn't point to any address. So it returns over here, string. This would be a null type here. We'd actually have to specify the type because null isn't a type, but it does return null. And that's what I'm getting at over here. So null is not equal to void. Some variations just to pound home the point. This will be a type mismatch. It says it returns void. Sorry, this is okay. It matches here, but the problem is in the call to method 1, it returns void. Method 2 calls method 1. It stores return value, a string. There's the type mismatch. Example 2 here. Let's see. Oh, okay. So we have a method returns null. Oh, it should be method 1. Didn't notice it in the other lecture. If we call this, or maybe that's method 3 here. We have multiple methods. Sorry, I have 1, 2. Make that one 3 here. Method 3. We can't store void in a reference, nor can we actually assign it to one of the primitive types. That's the point I'm getting at here. I have stressed the null and void aren't the same, but different variations. Wow, what if this? What doesn't matter if the what ifs. So returning something violates the syntax. A simple type, a primitive. This one is okay in of itself. Void returns nothing, but in the call here, this is where we have the problem. It's expecting a primitive. Memory types. This is the last of this section. When you run a program, it's in RAM. Run your program here. Pull up the let's try to pull background. Where's the darn thing? Let's pull up the task manager here. Pull up the standard way. For some reasons, yeah, not hugely important. This is an exercise I was working. Oh, there it is. Oh, maybe it appeared. I just didn't notice it because it was in that funny form. So you got all these programs appearing in RAM. Zoom is the one under my account that's taking up the most space. When you have a program in RAM, it's given the memory is segmented into parts. We have the instruction space. So inside of RAM here, there's the machine language instructions loaded into RAM. But we also have other things. We have some buffer, free memory, as we need more memory. What do we need it for? Well, things like local variables. So that's going to be in addition. Sometimes you'll see programs actually grow bigger. That's one reason. So what are we doing? We're calling another method. We pass num and a reference to a person. On the receiving end, inside of another method, parameters you should know at this point, or they don't just magically store the value at num, but they're stored in local variables. And they are stored in a memory, local variables, in the memory called the stack. It's called the stack because you don't need to know an exam, but in case you're wondering, it's like a stack of plates. We stack things on top in memory. These are numeric addresses, kind of like mailboxes. So NUM goes first. Then the address of a person goes, and we start stacking it. When we want to retrieve it, we push them on the stack of plates. When we want to retrieve it, we pop them off. And that's how we retrieve the values. And in 355, second year course, when you're actually writing assembly language code, you don't have the nice option here when you call, it's called a subroutine of just passing it and magically handling it. You have to, with machine language, with assembly instructions, create that stack yourself. So you're pushing this memory location, it's not a name, but a numeric address onto the stack. You push this onto stack, push this onto the stack. When you want to retrieve it, you pop it off the stack. As you call that method or function, you start stacking things more. That's why this is growing. In addition, we have locals that go on the stack. Coming from another direction that's allocated, all this again is for your program. Each one of these programs have memory associated with it. This right now is their current usage of memory. But as we actually execute functions, we use stack, but there's also the heap. The heap, I don't know the name for it, it's dynamic memory essentially. So in Java at least, it's dynamic whenever we grab memory or allocate memory on the fly. So we actually we only create a person object here. We didn't create it here. We grab memory on the heap. We have an array. The new keyword indicates it. This doesn't take up a lot of memory. But if we had a large array that was taking up a gigantic amount of memory, that would actually take up more and more heap. So these two start going together. And with languages like Python and Java, if we actually start using up too much memory, say with the stack space, you're given a certain amount of memory in Java by the Java runtime environment as you're running this. If you exceed it, then it's a runtime error, and that's a good thing. Because in languages like C, where they don't control the memory, you can not only exceed it, but you can blast past the bounds of an array. What happens then? If I'm in the heap here, and we have another array beyond this array, we start tracking, potentially overriding another array. And it gets really hard to debug, because you look for the other array, say array 2, where have I trashed those values? Well, I haven't. I've trashed it through this array. If you go far enough and you start using memory, and we're not exceeding the bounds of an array, maybe we're creating big objects, then what can happen essentially is we use up the free memory, it crashes, and I'll show examples here. Running out of stack memory. So we have an endless recursive example. The only thing that gets pushed onto the stack is a long 8-bit value. It could be even a Boolean, 1 bit, but it never stops, calls it again. Each time it calls it, it allocates 8 bytes. We call an infinite number of times theoretically, essentially stack, stack, stack. It's enough that we've exceeded our allowable stack space and it crashes. And you can just copy paste this program, have it run yourself, and maybe have main call it, for instance, easiest way of writing this, and make it static. Another way you can run on memory is with the heap space. We have basically a big object. I had first written code to allocate memory for a big object, then some sort of structure like an array for this. But then the code was so complicated that the learning lesson is when we start creating a big object, it takes up gigabyte. How we do it's not important. And then we create 1,000 big objects, say terabyte. This is 1 gigabyte. We have 1,000. Sorry, that's 1 gigabyte. That's a terabyte. 1,000 times a giga is a terabyte. That's more RAM than we have. And even if we have memory go onto the hard drive, that's gonna beyond our allowable limits. So we create a big manager. The problem is we run out of heap as well too.